Hey guys, this is part 3 video for section 3.2. So we had done some FOIL problems here up above, and I would like to point something out to you before I pick it up here with number 7. So if you look at the answer we got for number 4 right here, we ended up with what's called a trinomial, right? 3 parts. This guy has a trinomial 3 parts, and it's typically what happens when you do a FOIL problem. But this guy only ended up with 2 parts, and the reason being these two middle terms canceled each other out. So check out what happens on number 7 here. So I'll show you a third way to do a FOIL problem here in a second, but for now I'm just going to do it the way most people do. That's the first thing in the parentheses times the first thing in the parentheses. We're supposed to add the exponents. I got x to the fourth. If I times that guy on the outside times the other guy on the outside, and if I add the exponents, because that's the rule, right, for multiply, I get an x to the third. Multiply these two guys. Negative 8 times x squared would literally be negative 8x squared. And the last one times last one, the last thing in the parentheses, negative 8 times 6 would be negative 48. 6 had an x, I got an x. So the question would be, can I combine an x to the fourth with an x to the third with an x to the second with an x to the first? And the answer is no, they're not like terms. So on this one, we actually end up with an answer that's 4 parts to it. It's called a polynomial. Now I'm going to skip number 8 and come back to it because I want to show you one more way to do a FOIL problem, but it's better to illustrate the box method by doing one of these guys down here. So way back in elementary school, do you remember doing multiplication tables? A multiplication table would be just make a box, put a bunch of rows and columns in it, put some numbers out to the side, and then you would times the numbers together and fill in the box. Well, we're going to do something very similar to that here in these two problems. So I'm kind of lazy. I'm going to put my box right underneath that second trinomial. I'm going to make a box that has 2 rows and 3 columns. Well, why 2 rows and 3 columns? Because the first part of the problem has 2 things to multiply, and the other part of the problem has 3 things. So I'm going to multiply row times column. So I'm going to go 3x, that guy, times that guy. I'm supposed to add the exponents. I get 3x to the third. That guy times the middle guy. 3 times 5 is 15. I add the exponents. I get x to the second. And the last one, there we go. So the negative 2 on this row, start over times that guy. Negative 2x squared. Negative 2 times the 5x, negative 10x. And negative 2 times negative 8 would be positive 16. So I'm just basically doing a times table. Now before, when we did FOIL problems, you would take the second step after you've done all the multiplication is to add up or combine what's left over. And we're going to do the same thing with the box method. So I want to add up the stuff in the box. Well, there's a 3x to the third, but I don't see any other x to the thirds. Now, I like crossing them off as I go. You don't have to do that, but I know I'm done with that guy. And conveniently, these guys usually, not always, but usually line up diagonally for you. So I see a negative 2x to the second and a 15x to the second lined up diagonally. I'm going to add those together. And remember, when we add, we don't change the exponents, so I'm going to leave that as squared. I'm going to cross those 2 boxes off because I know I got them. So I'm going to add a negative 10 and a negative 24 for a total of negative 34. And then obviously I get a 16 left over. And that's it. That's multiplying with a box. So I do think that's easier. So if that first box was 2 rows by 3 columns, and on number 2 I have a trinomial times a trinomial, I'm going to go with a box that's 3 rows and 3 columns. Feel free to make the box bigger than I'm making to give yourself lots of room to write in. Tough enough for me as it is with this pen. So I got a y to the second in that first one. I got a 4y in the middle. I got a negative 1 on the end. So it's just a matter of me multiplying the stuff out. Alrighty. So y squared times 2y squared. Add the exponents, I get 2y to the fourth. y squared times negative 6y to the third. The other thing I like about the box is the exponents are going to go downhill. So if I had a y to the fourth in the first one and a y to the third in the second one, the odds are pretty good that guy's going to be a y to the second. And that works going this way as well. So if I had a y to the fourth up above, that guy's likely to be a y to the third. If you add the exponents, he is. Multiply the middle ones down to a y to the second. Multiply the 7 on the end. I'm down to y to a first. Well, what happens if you multiply everything times 1? It would stay the same. What would happen if you multiplied everything times negative 1? The signs would change. So that guy would be negative, that guy would be positive, and that guy would be negative. And then it's just a matter of adding up what's in the box. So I've got a 2y to the fourth, but I see no other y to the fourth, so that guy's done. Cross them off. I got an 8 minus 6 for a 2y to the third. Cross those guys off. Negative 2 and negative 24 is negative 26. And 7 would be negative 19. Use a calculator for that if you wanted to. Exponent doesn't change. I got a 6 and a 28 for a total of 34y. Got those two. And there's my minus 7. And that's it. It's done. So multiplying the box, I think, is really easy. So you might be asking yourself, hey, can I do FOIL problems with the box? And the answer is yes. That's why I saved number 8 up here. Now, number 8 is one of those ones that drives me insane. If you look at number 4, how many sets of parentheses do you see? For number 5, I see 2. 6, I see 2. 7, I see 2. And a FOIL problem involves one set of parentheses times another set of parentheses. So it would be really tempting on number 8 to just square the 2n and be done, and square the 9 and be done. But what's it mean to square something? Squaring something means you take whatever it is, in this case 2n plus 9, and times it by itself, 2n plus 9. So now I got a FOIL problem to do. So I got more than just squaring that 2 and squaring that 9. So again, the question being, can you do this with a box? And the answer is yes. So if you like the box method, feel free to do all your FOIL problems with a box. So I got 2n plus 9 to multiply. I got another 2n plus 9 to multiply. And man, is my hand getting tired. All right, 2n times 2n. Remember, guys, you are adding the exponents when multiplying. So I got 2n squared. 2n times 9, 18n. 9 down here times that 2n up there is coincidentally another 18n. And then I got a 9 times a 9 for 81. Add up the stuff in the box. I got a 4n squared, but I have no other n squareds. That guy's done. I got an 18n and an 18n to add up. That's a total of 36n. Now remember, since we're adding, now we're not doing anything with the exponents. We want to leave n the same. And I got a plus 81 to stick on the end. And that's it. So let me scroll back up here. So if you see all these other FOIL problems we did them a couple different ways. On number 4, I listed out FOIL and wrote it down. Some people like doing it that way. On 5, 6, and 7, I just did them. In other words, I just picked them out, the parts, and multiplied them together and wrote them down. But I think for all intent and purposes, the box is the best way to go. Most people will be most accurate using that method. So feel free to do FOIL problems that way, and most definitely these guys down here at the bottom, you almost have to do it with the box method. Now there is a way you can just do the distributed property multiple times, but it's easy to lose track. With the box, it's hard to lose track because on number 2, if you know there's 9 boxes to fill in, well, you're not going to miss one. So you're going to get all 9 multiplications. All right, guys, that's the end of part 2 video. Actually, that's the end of section 3.2 videos. Thanks for watching.